And then Jupiter is having a dramatic impact on underneath the ice because when Jupiter it basically has a tidal force pulling on Europa, and because it's rock in the center and ice, rigid ice above, it's pulling on Europa the same way as the moon pulls on the Earth, and we get tides. And we get tides because the gravitational pull of the moon is pulling our planet, and our oceans respond, which is great because that ocean water is flexible and it can respond, and then we get tidal surge. But when you have that rigid ice and the rigid rock, it's going to pull, but you don't have that flexibility, right? You don't have that flexible liquid outer surface. So instead what happens is it pulls on that rock, and that rock basically heats up because of it, the same way as if you were to rub your hands together from friction. So that rock heats up, and then you get geothermal activity, which can then warm that bottom of the ice and create your liquid ocean. So the fact that Jupiter is there is driving the potential for an ocean to begin with. So it has a massive impact on the moon. Yeah.
Do you remember past movies that are trying to have some angle up here to really forward it? What could be the danger to the organisms that pull over us?
Oh, that's a good question. So, what could be the danger to organisms that might be in the liquid ocean in Europa if we sent a probe down that actually opens then a channel going from the surface of the planet down to that liquid ocean? That's a great question. And actually, have you heard of Lake Vostok before? No? So there are these underwater lakes in Antarctica that have not been exposed in millennia. And so that is something that researchers are trying to figure out on our planet now, is how to actually tap into these places that have never been that haven't been exposed to humanity or modern times in millennia, without totally destroying then whatever ecosystem has evolved there. So hopefully that's something we figure out before we actually send the probe into Europa. Good question. So how would there actually be tectonic activity in the ice shell of Europa without those sheets just breaking? You actually do get, we expect that there would be fractures. And so, let's see. So you see all these crisscross marks on Europa. The hypothesis is that those crisscross marks are basically fracture lines. So those are fault lines, the same way that we have fault lines on planet Earth. It's where that rock moves and it breaks because it's rigid from that tension. And it's believed that the same thing is happening, but in this case it's happening with the ice instead of rock. They could be very deep. But for the most part, you would think of, have you heard of the San Andreas Fault? Yeah, some of you have. It's basically this fault line. It goes through California. It's kind of a region where there's going to be a lot of earthquake activity. And you can think of these scratch marks on the surface of Europa as an ice analog to that of the San Andreas Fault.
So, question. What's your opinion on, so Europa is close to Jupiter orbit, but what do you think are going to be the major issues with radiation?
Oh, great question. So what do I think would be the major issues with radiation, presuming coming off of Jupiter? Yeah, for life or for us, for our missions? Is your question with regard to life on Europa?
How would that change it, and would you expect altered?
Yeah. So we think that that radiation coming off of Jupiter would probably not make it down to that surface ocean or subsurface ocean. And so it's really that we don't expect to find life on the surface of Europa the way that we have life on the surface of Earth. But that radiation from Jupiter actually causes a lot of interesting chemical reactions in the atmosphere that we think could then be transported through the tectonics and potentially then fuel some life in the subsurface ocean. Yeah. Oh, what method is the probe going to use? That has not been decided yet. One of the ones I've heard is that there's this type of missile. I think it's called like a bunker blaster or something. Basically, you shoot it really high up, and then it falls down. And because it's falling with such force, and it's got kind of a pointed angle, it's able to penetrate deep. And so I've seen a schematic of that type of probe where you would basically just allow it to fall from a very far distance, so it accelerated very quickly, and then would able to penetrate the ice. But I've also seen other probes that use more of a melting method, so it's totally not decided yet. But people are like out in the desert testing this stuff. 3 minutes left. All right. 3 minutes. Any questions? No? All extremophiled out?
Thank you so much.
Questions? Yeah. Thanks for the great questions, you guys.